Hello and welcome to Lesson 6.1. Today we're going to look at finding rates of change. When we're looking at rates of change, this is going to allow us to see a relationship between two quantities that are changing. If one quantity depends on the other, then the following is true. We can ultimately find the rate of change by looking at the change of the dependent variable, and dividing it by the change in the independent variable. And if you remember, the change in our dependent variable is going to be our y, so I'm going to write a triangle, which really means delta, or change in y's, divided by our change in our independent variable, which are the change in x's. So if you want to think about it in simpler terms, ultimately we're looking at our rate of change as being the vertical change divided by the horizontal change. And it kind of puts it in a ratio for us. So if we look at our first example, it wants us to find the rate of change and explain what it means. So I'm going to put ROC for rate of change. Remember, this is going to be like our change in the y divided by the change in the x. So if I look at my y values, as I go from left to right, I'm going to start out at 0, and I'm going to go up 2 to get to my next coordinate point here. So my change in y is going to be a positive 2. And then when I look at my change in x values, to go from 0, which I'm at right here, I'm going to have to go over 10. Okay, and I get that from looking at my scales here and here. So my change in x then is going to be a change in 10. So I end up with 2/10, or 1/5. So my rate of change is 1/5. So to interpret that, we have to look at what our y values represent. So I know that I have 1, and it tells me right here my y values are my distance in miles. So I'm going 1 mile for every 5. And then in this case, my x values are my time, or seconds. So 1 mile for every 5 seconds, or my rate is 1 mile per second is another way you could read that. Likewise, for example 2, we're still finding our rate of change and explaining what it means. So again, if I look at my rate of change is equal to my change in my y values divided by my change in my x. Okay, my change in y values this time, we can go pick another one. So I'm going to start out at an x value of 1, and I can see that this point here starts me out at 112. And to go to my next point down here, I'm going to go down from 112 to 96. So 112 minus 96 is going to give me that change in my y value. So 112 minus 96 is actually going to give me 16. So I really have 16. And then to go for my change of x, or to find that, I see that I started out at 1, and I'm ultimately going to be going over 1 box, so that I can get down here. So I'm going from 1 to 2, so that means 2 minus 1, which equals 1. So my rate of change is really 16 over 1, or 16. So to interpret what this means, I have to again look at my units. So my y values are speed in feet per second, so 16 feet per second, and my time value is in seconds, so I'm going to divide that by seconds. So here I have 16 feet per second, and I'm dividing that by 1 second, and when I do the math on my units, this right here is actually going to give me a unit of 16 feet. So what this means is I'm actually traveling 16 feet in that 1 second time frame. So the rate of change actually has another name for it, and what we're going to do is we're usually going to start calling this our slope. Now the slope indicates the steepness of a line on a graph, okay? And that steepness is actually our rate of change, okay? And we can find that, as we mentioned, by finding the vertical change, which we said was our delta y, and dividing it by our horizontal change, or our delta x. Now, sometimes you're going to hear about this being mentioned as our rise over run. Okay, so how much are you going up or down versus how much are you going left and right? Okay, but ultimately, the thing that you need to know is this right here. You need to write this down. You need to highlight it. You need to save it. Okay, this right here is an incredibly important topic, and this is what we call slope. Slope is y2 minus y1, which is our change in y, divided by x2 minus x1, or our change in x. Now, the one thing you have to keep in mind, though, is this little note down here where it says x2 minus x1 cannot equal 0. Okay, you can't, if you have a change in x, it can't equal 0 because you cannot physically divide by 0. It will give you an undefined value. So you cannot divide by 0. So looking at example 3, it says find the slope of the line through the 2 points. Now I'm going to write our slope. Slope is typically represented with the letter m, and we said that that's y2 minus y1 divided by x2 minus x1. Now when you're given 2 coordinate points, okay, it's kind of nice and it's really easy. It doesn't matter which point you call 1 and which point you call 2, but you have to be consistent. So I'm going to label this as x1, y1, and x2, y2. So now when I go to find my slope, or m, my formula says y2 minus y1, so y2 is right here. I have 7 minus my y1, which is 5 from the other point, and I'm going to divide that by my x2, which is 4, and I'm going to subtract 2, or my x1 value, from that. Once I have everything plugged in, I'm literally going to simplify. So this gives me 2 divided by 2, or I have a slope of 1. For the next part, I have 2 points again, and I'm just going to show you it doesn't matter. So if I list this one as x1 and this one as y1, then I have x2 and y2. I'm going to go to calculate slope. My y2 value is 4. My y1 is a negative 2. I am going to have to put in that negative in parentheses. And then my x2 value is a negative 1, and I'm going to be subtracting my x1, which is a positive 3. So now to simplify this, I have 4 minus a negative 2. Well, that's going to become positive, so I end up with 6. And negative 1 minus 3 is really, if I change this to plus a negative, I can see that I really have a negative 4. So ultimately, I have a negative 6/4, which is really a negative 3/2. So my slope in this case is a negative 3/2. Now, a negative slope tells me that we are decreasing as we go from left to right. So my slope in this case is going to be something that looks like this, if I were to graph it. As for in the top part, if I have a positive slope, it means I'm increasing as I go from left to right. And we'll look at that here in a little bit. For example 4, we're going to do the same thing. We're going to find the slope of each line. Now here, we're given the 2 points right here and right here, so 1, 2, and 4, 2. So again, I'm going to start out by labeling my points. I have x1, y1, and x2, y2. The formula for slope is y2 minus y1 over x2 minus x1. You probably should start memorizing that. Okay, so now when I go to calculate my slope for part A, I end up with my y2 value, which is 2, minus my y1 value, which is also 2, and I'm going to divide that by x2, which is 4, minus my x1, which is 1. So when I simplify this, I get 0 over 3, or I get a slope of 0. Okay, and that's okay. Now let's go ahead and do this for part B, and then we're going to talk about this for a quick second. So for part B, I'm going to call this my x1, y1, and this is my x2, y2. So my slope for part B is going to be equal to y2, which is 2, minus y1, which is -1, divided by x2, or 4, minus x1, which is also 4. So here I have 2 minus a -1 really becomes 2 plus 1, or 3, and 4 minus 4 is 0. So this here is actually undefined. So that means I have no slope. So this right here, this example, we have two specific cases. Okay, one, we have a slope of 0, and if you notice, a slope of 0 is actually coming from a horizontal line. Okay, that means it's not increasing or decreasing as I go from left to right. It's just a flat horizontal line. Okay, likewise, when I have an undefined slope, like what we did here with part B, an undefined slope comes from a vertical line, as you can see right here. Okay, as I mentioned, these are two special cases. So to kind of summarize what we've talked about so far, we have 4 different scenarios. If we have a line with a positive slope, as we see right here, this means we're going to be increasing as we go from left to right. So my graph is going upwards. If I have a negative slope, it means I'm decreasing as I go from left to right. If I have a line with a slope of 0, I have a horizontal line. And if I have an undefined slope, that means I have a vertical line. These are going to be 4 different cases that you should probably start learning to recognize. So now if we go and we look at example 5, it says find the rate of change and explain what it means. So when I'm given a graph, I will typically go and just pick a couple points that work out nicely for me. So here, I like to use 0, 0 if I can, and in this case I can. And then I'm just gonna go pick another point on my graph. So maybe I'm gonna come up here and I'm gonna pick the point 5, 15. So my coordinate points are 0, 0 and 5, 15. And again, you could have picked any point and it will still work out to be the same. So I'm gonna go ahead and label x1, y1, x2, y2, and I'm going to find my rate of change, which is also the same thing as my slope. So slope is y2, or 15, minus y1, divided by x2 minus x1. So this gives me 15 divided by 5, or I end up with a slope of 3. So what this ultimately means then, and if you remember, that's really 3 over 1. So this tells me that when I look at my y values, these are my points scored. So I'm averaging 3 points for every 1, and then my x value is baskets. Or you could say you're averaging 3 points per basket. Example 10 says to find the rate of change and explain what it means again. So here I'm given a table. Okay, now tables are essentially coordinate points because I could go ahead and wrap my coordinate points just like this. And so because I've already written the 0.575 as an ordered pair, I'm going to use that one, and then I'm just going to go and pick another one, and I'll take the last one for now. So I will label x1, y1, x2, y2, and I'm going to find my rate of change or my slope. So I have 120 minus 75 divided by 8 minus 5, or I end up with 45 divided by 3, which gives me 15, and if I needed it, it could be 15 over 1. So again, I'm going to look and see what does this mean. So my y values in this case are cost. So I know that I'm spending $15 for every 1, and then my x value is a ticket. So I'm spending $15 per ticket. For example 7, we're finding the slope. So again, when you're given a graph, pick points that are nice for you. Okay, and what I mean by nice is if I come and I look at this point here, I can get an approximation, but I'm not going to be exactly on point, especially because I don't have grid lines. So I don't want to pick a point like this one right here in between 2 and 3 because it's only an approximation. I'm going to pick points that actually show up through one of the crosshairs. So I'm going to try something like maybe this point here, which is 0, 160. Actually, I'll write this over here. So 0, 160. And then maybe I come over here to this point where I have 2 and 80. So my other point is going to be 280. And now I'm going to go ahead and find my slope. So m equals y2. Oops, so I'm going to go and label x1, y1, x2, y2. So this gives me 80 minus 160 divided by 2 minus 0. 80 minus 160 is a negative 80, and 2 minus 0 is 2. So this is going to give me a slope of a negative 40. Now, I have a negative number, which is fine. Okay, we just have to make sure that my graph represents that same negative number. Remember, a negative slope means that we are decreasing as I go from left to right. And if you look at my graph, we are in fact decreasing. So that means that I'm probably on track for doing what I'm supposed to be doing. My final example for the day says that we're going to find the slope, but here it says a baby is 22 inches long at birth and 33 inches long at 15 months. So in order to find the slope, I'm going to convert these over into coordinate points. So a baby is 22 inches long at birth. So when time, usually we put time as an x. So at time 0, this baby is 22 inches. So my coordinate point for this one is going to be time and length, just to define it. And then my next point says at 15 months, this kid is 33 inches. So now if I go and I find my slope, I'm going to identify x1, y1, x2, y2, which means I end up with 33 minus 22 divided by 15 minus 0. Well, 33 minus 22 is 11. 15 minus 0 is 15. So I can conclude then that this baby has a growth rate of 11 inches for every 15 months that this kid is growing. For the second part, it says a chef cooks 11 pounds of chicken for 10 people and 56 pounds for every 100 people. So if I write these out as coordinate points, so this is going to give me people for my x and pounds for my y. So when I write these as coordinate points, I end up with 10 people and 11 pounds of chicken, and I have 100 people and 56 pounds of chicken. So now to find my slope, I have x1, y1, x2, y2. My slope then is going to become 56 minus 11 divided by 100 minus 10. 56 minus 11 will give me 45, and 100 minus 10 will give me 90. If I simplify 45/90, this is 1/2. So really what this means is I have 1, and my y values, remember, are pounds, for every 2 people. So I get 1 pound of chicken for every 2 people that there are. So this is going to conclude the 6-1 video. Please let me know if you have any questions. Thanks, and have a great day.